What's up everybody? Today I'm going to be showing you a completely unique AI system I created. This AI is unlike anything you normally see. It's actually inspired by how real life cells work. And I wondered, if you scale those ideas up, could you actually get something that behaves like a simple biological brain? Let me explain how it works. Normally, when you train an AI, you use backpropagation. That tells the AI what was good and what was bad. And it has to be proven to make the AI excel at their task. But there's one problem. Once the AI is trained, it can't really change how it thinks during inference. It can only use patterns it has already memorized during training. You might say, why not just use reinforcement learning so it can learn in real time? But my goal wasn't to make the perfect AI. I wanted to make something that actually felt alive. That means the AI isn't strictly forced to maximize a goal. It can show unique behaviors, sometimes even suboptimal ones, based on whatever it's experiencing at the moment. And this works because my AI doesn't learn using backpropagation at all. Instead, it learns through evolution, using crossover, mutations, and competitions, and through lifelong learning inside each individual's lifetime. That means the AI can learn just by observing its environment, the same way real organisms do. Evolution is not optimizing their actions directly, it's optimizing its ability to learn. So, let's take a look at the code. Right here. As you guys can see, here are some parameters, number of agents. Brain size is basically how many parameters are inside the brain. The more you have, it's like the more neurons in a neural network, the smarter it can be. Here's alpha, which is basically how much the input affects how the weights are changing. I'll explain that a little bit later. And beta is similar to alpha but for something else. And then here's some of the evolution parameters. Alright, let's take a look. So over here, this is actually the main part of the script that differentiates it from other AI models, because as you guys can see, it's a bit like Hebbian learning, where the AI takes the input like this and it basically modifies its hidden states permanently, so it has some sort of memory of the past. And then you keep doing that for the output layer, which only looks at what the brain is doing, and then it outputs something. And the fitness, or basically which one gets chosen to reproduce, is based on if it's able to correctly move in the correct direction and by the magnitude. And you can also interact with it just by grabbing the food. So let's see. Let me just disable the script. And as you guys can see, it's not moving perfectly towards it because it's only been 15 generations, and yeah, it moves pretty fluidly and naturally compared to if you were to use a regular neural network, which would probably find the straightest path. But efficiency isn't really my goal over here. So that's basically it. I hope you guys enjoyed this video, and I'll see you next time.